Hello everyone, I am Dr. Kiran Mai, Area Chair and Assistant Professor, Digital Transformation and Operations, School of Business, Aditya University. In this present lecture, I am going to discuss how to find out initial basic feasible solution for a given transportation problem using least cost method. So, as discussed in the previous lecture, whenever we are going to solve transportation problem, first we have to find out whether the given transportation problem is balanced or unbalanced. If it is not balanced one, we have to transform, we have to make it balanced transportation problem, and then only we have to proceed to find out the solution, right. So, how to check out whether the given problem is balanced or not? We know that total demand must be equal to total supply. Then only the problem is considered as balanced one. Okay. So, total demand in this problem is 5 plus 8 plus 7 plus 14, which is 34. Total supply is 7 plus 9 plus 18, which is again 34. Therefore, the given transportation problem here is balanced transportation problem. Okay. Now, we can proceed to solve the initial basic feasible solution. So, among the entries, among the costs, using this, the term itself suggesting meaning least cost method. That is, we have to consider the cell which is having least cost. So, to that cell we have to make allocation, right. So, among all the costs in the cost matrix, okay, let us find out which is the least cost. Among all the costs, this 8 is least cost, which is S3D2, that is cell 32, right. So, to this cell we have to make allocation, right. Therefore, let us, so how much to be allocated? Look at the corresponding supply and corresponding demand for that cell. So, the supply requirement is 18, the demand is 8. Okay. So, whichever is less, that much is to be allocated between supply and demand. So, 8, this is less, therefore, allocate 8. So, this is how we have to make allocation using this least cost method, right. If we allocate 8 here, this total demand is supplied and here 10 remains. So, supply from this source, how many units can be supplied? 18. So, among 18, already 8 units are supplied, 10 more units can be supplied from S3 source. For destination 2, what is the requirement? 8 units are required, 8 units already we have allocated. Therefore, this must be striked off, right. This is how we have to start allocation for the cell which is having least cost using this method and strike off that column. Next, again don't consider, delete second column D2 and among all the other elements, all other costs, again find out which is the next least cost. Okay, here it is 19, 70, 20, 40, 50, 40, 70, among all 10 is least cost, that is cell 14. So, to this cell we have to make allocation. So, again look at the corresponding supply and demand requirement. So, the supply is 7 and the demand is 14, whichever is less, that much we have to make allocation. This is less, therefore, allocate 7 for this cell, allocate 7 for this cell, strike off this 7, that is this row we have to strike off, and out of 14, the demand for this destination is 14 units. So, 14 minus 7, 7 more units are to be supplied to destination 4. Okay. So, this is how we can make allocation in the first iteration. Next. So, after that, again in the leftover matrix, delete second column, delete first row, and among the other costs, which is the least cost, 70, 40, 60, 40, 70, 20. 20 is the least cost. So, to this cell we have to make allocation, right. So, corresponding supply demand is 10 and 7 respectively. So, whichever is less, that much we have to allocate. 7 is less, 7 units, strike off this 7, strike off this column. 10 minus 7 is going to be 3. Okay. So, this is how we have to give allocation, and proceeding to the next iteration. So, next among the leftover matrix or elements, 70, 40, 40, 70. 40 is lesser. We have two 40s, whichever arbitrarily you can select at random any of the cell containing 40 as the least cost. Okay. So, we can make allocation to cell 2, 3. Okay. So, here the supply is 9 and the demand is 7. Therefore, 7 is less, 7 units can be assigned to this cell, and this column will be deleted. 9 minus 7, 2. And let us proceed to the next iteration. And among all other, how many elements are left over? 70 and 40. 40 is lesser. So, 5, 3. 3 is lesser, allocate 3. 5 minus 3 is going to be 2. Okay. So, this is how we can make allocation. Next, 70 is the only cell which is left over. So, 2 is the demand, 2 is the supply, allocate to here. Okay. And then, so now total demand and total supply, all the units were allocated. Okay. And now, let us look at the optimum solution. And before finding the optimum solution, we should check whether this solution is going to be degenerate or not. Degeneracy also we have to check it out. How can we check degeneracy? M plus n minus 1 must be equal to number of allocations. Then only the solution is considered as non-degenerate. Okay, M represent number of rows, N represents number of columns. Okay, so number of rows 3, number of columns 4 minus 1, that is 7 minus 1, 6. How many assignments or allocations we have got in this IBFS using least cost method? Let us see. 1, 2, 3, 4, 5, 6. So, M plus n minus 1 is equal to number of allocations. Therefore, the solution here in this problem is non-degenerate. Okay, and let us find out what is the total minimum cost according to this allocation. So, in this first row, we have given allocation of 7 units and the cost of each unit is, transportation cost of each unit is 10 rupees. Therefore, 10 into 7, and here 2 units, per unit the transportation cost is 70, 70 into 2. Likewise, we have to calculate for all the allocations, then minimum transportation cost is going to be 814 rupees. So, this is how we can find out the initial basic feasible solution for the given transportation problem using least cost method. So, finally, and another thing we can also understand that 7 units are to be supplied from, in order to minimize the transportation cost, 7 units must be supplied from S1 to D4. Next, 2 units must be supplied from S2 to D1. 7 units must be supplied from S2 to D3. So, this is going to be the optimum allocation, right. So, this is how we can find how many units are to be supplied from each source to each destination so as to minimize the transportation cost using least cost method. So, by the end of this lecture, you will be able to understand how to check whether the transportation problem is balanced or not, how to make allocations using least cost method, and also finding out whether the solution is degenerate solution or non-degenerate solution. Thank you.